Thanks, Doug. You hear me? No? Can you hear me now? Okay. Thank you, Doug. So again, my name is Matt Lord. I'm a product manager in the MySQL group at Oracle. And I'm going to try and go through these really quickly. I know that we're already running a little long, and I've got quite a few slides. But I wanted to at least cover the highlights of the highlights. MySQL 5.7, we've got our second release candidate, was made available just a few weeks ago. And there's a ton of new stuff in 5.7. So again, I'm going to just kind of touch on the highlights of the highlights. I have links on the last slide. This presentation will be made available later on by Tesora. And so I encourage you to look up some additional information. It's by far the biggest release that we've ever done as MySQL. So there's something in it for everybody. Even if you're not interested necessarily in any of the new features, I would encourage you to upgrade to 5.6 and then to 5.7, if nothing else, for the increased performance. So with each release, we identify and we eliminate certain hotspots, bottlenecks. Typically, it's mutex usage. So by splitting various mutexes, moving to atomics, looking at our synchronization primitives, we're able to scale up much more effectively with each release. So of course, we want to be able to scale horizontally as well, which we'll talk about, group replication, for example. But being able to scale up is a big part of the full scale picture as well. We also have some NoSQL APIs to MySQL. This was actually added in MySQL 5.6. So we have the Memcache D API, which you can talk directly to the storage engine, which is InnoDB. And Facebook was one of the early adopters of that technology, and they gave us a lot of feedback that was extremely helpful. So Facebook operates at a scale that not too many other entities do. So they gave us a lot of great feedback. Helped us with a lot of improvements that you can see there in the 5.7 numbers compared to 5.6. This is another area where Facebook was a big help. So they still use PHP. Their own modified version. They have their hip hop VM, which is but it's still based on PHP, which in practice means that they have a lot of connects and disconnects. There's not a big connection pooling layer. So when you don't have a connection pooling layer, of course, you're making tons of connects and disconnects. So we made a bunch of, or some pretty serious improvements to how quickly we're able to handle connections. So doing the handshake, doing the authentication, and so on. Optimizer improvements, we made a bunch, or a number of them in 5.6, most notably related to subqueries, but we've made far more in 5.7. So this is just kind of some highlights of them. So we have a new cost model. So before, it was almost entirely based on heuristics. There were some costs involved, but they were all essentially static costs. So now we have a configurable cost model. There's cost model tables in the system schema, the MySQL schema, that you can actually go in and modify those as well. So you can go in and modify the cost of a disk read, for example. So if you're using a SolidFire or a Nimble storage flash array, you're going to have a much different I/O cost than if you're just using a single SATA disk. And those costs are built throughout, and we also expose them through JSON. So we have a new JSON-based explain, which was new in 5.6. We've expanded it. So anytime we add new costs, we also expose them in the explain. And I'm going to have to skip through just because of time. But again, I wanted to put the slides in there, even if I couldn't spend much time on them, just so that you can download them later. The query rewrite plugin. This was really helpful for a few specific use cases. So for example, if you want to build your own firewall, and we actually leverage that for an enterprise offering as well, some of the similar things. Or if you just have a third-party application that you're using, so maybe you inherited it, or you're just using it and you can't go in and modify the query. So there are certain times where even the best optimizer doesn't pick the optimal path. So then you can go in and you can add index hints, for example. So this is one way that you can do that even when you don't have the ability to modify the application or the queries directly. If you've been using MySQL 5.5, 5.1, you've almost certainly run into cases where you needed to try and solve a performance-related issue, and you ended up having to make educated guesses, in some cases less educated than others. Because MySQL is a bit of a black box. Before MySQL 5.6, where we really started to add a lot of instrumentation to performance schema. And we've added a ton of additional instrumentation in 5.7, as you can see a listing here. So one of the big ones is memory, but also internal locking, transactions, store procedures. So we filled in a lot of the gaps that we had in MySQL 5.6 if you've been using 5.6. And in conjunction with that, we lowered the overhead a lot. So one of the issues, of course, there's always a trade-off between monitorability, logging, debugging facilities, and so on, and performance. So we've been able to lower the performance overhead of performance schema while at the same time adding new features. And we've also made it a bit more accessible for the average user. So if you look at performance schema directly, there's a ton of tables, there's a ton of different options, and it can be a bit daunting. It can scare people off at first. And so we've added the sys schema in 5.7 as well, which is just a collection of helpful views, store procedures, stored routines that really make all of that data that's in performance schema more accessible. Provides it in a nice user-friendly format, and it allows you to easily answer common questions. Like what queries are using up, are resulting in the most I/O? How is the I/O usage broken down by table? What is blocking this particular query, and things like that. JSON support is one of the more headline features. It's certainly something that a wide swath of people are interested in. So we have a native JSON type in 5.7. We also have a native binary format. So if you're using MongoDB, they have their BSON format. We have our own internal binary format, so things operate well performance-wise, although when it's exposed via the query results, it's just native JSON. We also have JSON functions. We have the syntax that we support conforms to the proposed SQL standard. So there's an SQL standard proposal out there for SQL, or JSON in SQL rather. And so we conform to that standard. And in 5.7, we also support generated columns. So if you're familiar with SQL Server, it's very similar. So we support generated columns that are both either persisted or stored. So you can create virtual generated columns and then add indexes on them to achieve what's often referred to as a functional index. So that allows you to then query the JSON efficiently. So you can add an index on the result of some JSON document lookup. GIS is one area where MySQL has historically been behind on the open source world, behind PostGIS. And so we're really looking to provide a solid foundation for MySQL users, because it's come up before, polyglot persistence. One of the common cases for MySQL users, they may have a PostGIS system set up just for GIS needs. And so we really want to provide a GIS system internally in MySQL that it eliminates that use case. So if you're a MySQL user, you're not forced to go off and set up a separate PostGIS instance just for whatever your geospatial needs are. And you can see a rundown of there. One of the big ones, or the single biggest one, was that we added spatial indexes support to InnoDB. Previously, it was only for the MyISAM storage engine. But we also added a bunch of other things like GeoJSON, GeoHash. We also ripped out the internal implementation, which probably isn't of too much interest to you. But we hired two of the primary developers from Boost.geometry. And so they've been working with us, and then we commit that code back upstream to Boost.geometry. InnoDB is the primary storage engine. If you're not intimately familiar with MySQL, you might not even know what I'm talking about with storage engines. So if you're using MySQL 5.5, you're just using InnoDB without even knowing it. Well, we've added native partitioning. So we've had partitioning for some time, but it was just a generic partitioning support. So you had this intermediate handler layer. So we have native support, so it eliminates a lot of the problems that we've had with partitioning, namely around the number of file descriptors that are used, the memory that's used. We have CJK support for full text indexes. So InnoDB supports full text indexes as of 5.6, and now we have 2 CJK related parsers. We have a MeCab parser and an ngram parser. I mentioned the native spatial indexes already. We use R-tree indexes for that. We support larger page sizes. So using those in conjunction with another feature I'll talk about, which is transparent page compression, that allows you to get much better compression ratios. So the bigger page size, the more redundant data you're going to have in the page, and the better compression ratios you can get. We had a general tablespace support. So now let's say you have an internal organization or a customer. You can create all of their tables in a shared general tablespace. So it makes it a little bit easier for migrating things at the file system level. So for example, you can have a single IBD file for a given customer or a given internal organization. Group replication I'm going to talk about in just a minute. Security is always an important topic, especially in the cloud, where literally and figuratively you may have other eyes on your data. You don't have the physical control over its location. So being able to support data encryption while in transit and at rest is important, and we've done a number of improvements there. We've also helped with general security issues with password rotation policies. We can notify you if someone is using a weak password and so on. SSL, I already mentioned in general, but we've had 2 notable things. So one is a new helper script. So when you initialize MySQL, it will bootstrap itself now with MySQL 5.7. So you don't need to run MySQL install DB, that separate script. So you run MySQL d -- initialize. And if you don't already have SSL certificates set up, it'll create those SSL artifacts for you. And you can also use this separate utility, this MySQL RSA setup utility as well. You can also require secure transport, which is something that you could never do before. It was actually a bit of a cause of some confusion. So there was previously no way to require SSL connections. And now you can do that with MySQL 5.7. Server-side timeouts is something that people have requested for a long time. So this is a long-standing feature request from users, so I thought it was worth mentioning. So now you can specify a global timeout. So any read query, you can say globally, I want it to time out at 20 seconds. So for example, some developer added some query, and it scans a 2 billion row table every time it's run, and it's run every time someone logs in. That'll give you a chance to kind of protect your machine from total failure in the event that certain things come in. And then you can also do it per query. As you can see in this example here, you can specify n milliseconds using this new hint syntax as well. So we have a new hint syntax, and I mentioned that in the optimizer slide, or I listed it rather in the optimizer slide. But it's much nicer if you've ever used the hints before. They were kind of spread all over the place. Now we use, in conjunction to the old one, we now support this, which is familiar to an Oracle database user. So it's right after the select, insert, update, delete, and then you can specify any number of hints using that new syntax, which is much easier than if you having them all over the place when you get into really long queries. We've also added a bunch of new hints, but again, there's so many new things in 5.7. I'm just giving you the highlights of the highlights. Again, I encourage you to go talk to one of us, talk to a MySQL salesperson, look at mysql.com, and you can find out all the details. So as Doug mentioned, we added GTID, or Global Transaction ID-based replication, in MySQL 5.6, and we did some major enhancements to that in 5.7. So the biggest one is that you can move from the old style of replication of binary log and position to GTIDs as an online operation. We also enhanced the semi-synchronous replication that we added in MySQL 5.6. So going back to MySQL 3.2.3, when we first added replication, it was just asynchronous. In MySQL 5.6, we added support for semi-synchronous replication. So you can say, I don't want you to do the local commit until you get n nodes that have said, okay, we've received this, go ahead and commit it. The multi-source replication is another one. So with multi-source replication, before you always had one slave to, one master to n slaves. And now it can be many to many. You can have, a slave can have many masters. So you can do things like fan-in replication. Performance, again, is always a big issue. So another thing that a lot of people have kind of glanced over in 5.6, something that we've improved even more in 5.7 is the slave performance. So if you've been using MySQL for any period of time, you've probably come across slave lag. It's just a common issue that you have to be aware of. So with asynchronous replication, the slave can fall behind n number of transactions or n number of seconds from the master. So we added parallel replication in 5.6, but the parallelization was done based on schema. So if you had queries coming in for n schemas, we would execute them in parallel. But now we've made that logical clock-based, so now you can get parallelization regardless of the schema. As long as there are non-conflicting writes, we'll do that. And we leverage some of the binary log group commit stuff from the master. And you can specify n number of threads on each slave in order to do that. I'll skip over that. It just talks a little bit about the GTID online operations. And this is just highlighting the multi-source replication. I say multi-source. Some people have called it multi-master, I've noticed, which leads to confusion, because this isn't what I'm going to talk about shortly, which is multi-master or write-anywhere replication. That is another thing that that's new in 5.7. So general HA improvements. Group replication is probably the biggest, which I'm going to talk about in just a second. But we've added a lot of little things that really help for us internally with MySQL Fabric, but also any tooling. So we've added some server-side stuff that really helps understand when a connection can be moved from one server to another. So am I in the middle of a transaction? If I am, then I can't migrate that connection from one instance to another. But if I'm not, then the load balancer is free to move that connection around. Server version tokens, which help with caches. So if you have a caching layer, then that caching layer can compare its version token to the one that's currently on the server. And if they don't match, then the caching layer can go ahead and reload its cache. And we use that and leverage that in MySQL Fabric. So group replication, I think, is, as far as HA and replication goes, it's the most interesting, single most interesting feature. So I'm sure a number of people here are familiar with Galera. So Galera replication and MySQL group replication at a high level are very similar. They're both based on the same academic papers from the late 90s, the replicated database state machine academic papers. But the implementation differs. There are two, so at a high level, it's multi-master, write anywhere, synchronous replication. The differences between the two is Galera is a bolted-on product, so it's a third-party product. It has its own options, its own logging facilities, its own debug facilities, all the WS rep stuff if you've used it. Whereas group replication is baked in, so it uses the same options, the same parallel applier code. It uses the same debugging facilities and performance schema and so on. So from a DBA perspective, one is learning another product, and the other is now you have the option of asynchronous, or asynchronous, semi-synchronous, or synchronous in effect. The other main difference that I'll talk about is how they handle the not so rare case that one of the nodes in the cluster becomes much slower. So you have a 4-node cluster in each, and the performance drops off for whatever reason. So Galera will degrade the performance of every node in the cluster to match the slow one, so that they're all in synchronous replication. Group replication will silently degrade, or I should say, move the one slow node out from synchronous replication to eventual consistency. And then once things come back, it will ensure that it's consistent in a synchronous member of the group again. So there are trade-offs there, and I would like to see us have a configurable choice there. But I think those are the two big differences between the implementations. I mentioned native JSON support. We also, in the labs, in MySQL labs, which is where we release beta, non-GA releases of stuff that, aside from the MySQL server. So certain add-ons or features. And this is an example of one, which is HTTP plugin. So not only can you use JSON internally, but you can set up an HTTP plugin on the server so that rather than sending normal SQL to MySQL, it can also speak JSON over HTTP. So you can send basic CRUD calls, or you can make document-oriented calls. And I'm running out of time here, I know. So I apologize. I'll just quickly, so this is kind of the MySQL official tool for handling sharding and HA. So each HA group that you see in this picture is managing a shard. And Fabric will then handle two things. So it'll handle the sharding aspect. So you have the query comes in and it will direct it to the appropriate shard. And then it will also handle the HA within each HA group. So it monitors the nodes. If one of them fails, it will handle the promotion, the demotion, and so on. And group replication can be used in there moving forward, so to improve the characteristics of each HA group. So you can have, in theory, you can write to any of them, although you still probably want to have some of them read-only and some of them read-write. And this I'll skip over. Again, we moved from what we used to use years ago, which was Bazaar. Or even before that, we used, I'm spacing on the name now. We used this old proprietary versioning mechanism. Now we moved to Bazaar. And now we moved to GitHub, which just makes it easier for people to work with us. So we have our code available on GitHub. You can even submit pull requests and so on. BitKeeper, that's the old one we used to use. If you don't already know, we also have official MySQL repos. So we have Yum repos, we have apt repos for Debian, for Red Hat, and so on. And this is just additional info. Again, this was just the highlights of the highlights. 5.7 is a huge release, really excited about it, so I encourage you to go find out additional information. And I doubt we have time for questions, but feel free to come talk to me. I'll be in the back there by the little Oracle table. And that's it. Thank you.